Greeting to Dr. Ashraf. We are from Group 2.10 and would like to present our group assignment for the course EIA2011 Introduction to Computer Assisted Data Analysis. First and foremost, before we jump into the assignment, I would like to firstly introduce our group member in our group. The name and the metric number of each group members are shown in the screen. Next, let us move to the scenario that is assigned to our group, which is scenario 2.3. Dr. Johnson recently uploaded a 1-hour recorded lecture for his course of 300 students. Along the lecture, he conducted a survey to gather insight about his students. The survey includes following questions. First, what is your age? Second, what is your sex? Third, are you a local or an international student? Fourth, what is your primary mode of transport used to get to the class? And lastly, what is your primary note-taking approach in the class? For question 1, based on the response collected, refer to scenario 2.3 Excel sheet. Describe Dr. Johnson's student in terms of their age, sex, student types, and also the primary mode of transport. Firstly, we would like to start question 1 with the student age analysis, where we will show you with the Excel working and also the summary of the data that we get.
The working in the Excel start with the mean, where we use the formula average and select all the data in column A before we click enter. So the answer will be shown on the table. Next, we will proceed with the mode, where we use the formula of mode and select all the data in column A. For median, we will use the formula for median. Next, for the maximum value, we will use the formula max and select all the data of age and also click the enter to show the result. Last but not least, for minimum value, we would like to use the formula of min, min, and select all the data in column A. For the distribution of student age, we would like to calculate the frequency of it by using the formula count if, bracket, select the range in the column A. Criteria, we would like to put a double quotation mark and label with 18, 19, 20, 21, and 22 respectively. To confirm that all the sample we have already included in our calculation of distribution of student age, we will use the formula sum and select all the frequency that we get from the 5 of the group and then click enter to see if we get 300, which is the total number of the student in the class of Dr. Johnson.
Now, here is the summary of student age analysis, where we have the measurement of mean, mode, median, maximum value, and minimum value with the respective formula and answer. Well, for the distribution of student age, we have formed a bar graph to visualize the data that we have got on the screen.
Now let's come to student sex analysis. First, we're going to use count if formula. Then we select 6 column, which is B. And then we key in male to get the number of male, which is 148. Same goes with female. We also use the same formula to get the number of female. B and then plug in B female to get a number of female, which is 152. And for total, we use the sum formula and select the number of male and female to get a total, which is 300. To get a percentage, just select male or female and divide it by the total. Then we get 49% for male and 51% for female. This is student sex summary with the numbers and percentage. We are using pie chart to visualize the sex distribution. Now let's come to type of students analysis. For type of student, we are also using the count if formula again. We select column C and type local student to get a number of local student, which is 280. And for international student as well, type count if formula and select column C and type international student to get a number of international student, which is 20. And for total, we use the sum formula again and select the number of local and international student to get a total, which is 300. To get a percentage, we need to select local or international student and divide it by the total. We get 93% for local and 7% for international student. This is the summary of type of students. We are using pie chart to visualize data. We can see that the majority of participants in this survey were local. Now let's come to students transportation analysis. For student transportation, we use count if formula, select column D and type motorcycle to get a number of motorcycle, which is 101. And we also do the same thing for car, working, bus and cycling. So for car is 152, Walking is 6, bus is 35, and cycling is 6. Then we use some formula to get the total, which is the 300. And to get percentage, we select one of the transportation and divide by total. There will be. Here's the summary of transportation. We are using bar chart to visualize the data, and we can see that most of the students are using car as their transportation.
Next, for question 2, question is asking if a group of 15 students is selected randomly, what is the probability that at least 5 of them do not take notes? Use the dataset to determine the relevant probability distribution. Create a visualization of the probability distribution to illustrate the probabilities for different numbers of students from 0 to 15 who do not take notes. Express the probability values in 3 decimal places. To answer question 2, first we have to count the number of students do not take notes. So we use the command count with. In Excel, we type equal count with data. So refer to the column of notes, and we type no notes, and the answer will be 53. Then we calculate the probability students do not take notes. So simply just divide 53 by 300 equal to 0.177. Then we create a table, calculate the binomial distribution, binomial probability from 0 to 15. We use the command binomial distributions. So taking 0x example, first we do for the x equal to 0. We type equal to binomial distribution 0 and 15. 15 is the total, the trial number, and the probability 0.177, and we type false. False refer to the mass probability distribution, and we get the answer 0.054. Then we drag down the cursor until 15. Then we will get all the probabilities for x equal to 0 until 15. So next, we're gonna find the probability at least 5 students do not take notes. We have 3 methods here. For the methods 1, use 1 to minus binomial probability of cumulative 4. Then we have method 2, 1 minus 5 number, which is 0 until 4, to minus the sum of the 4 probability from 0 to 4 from the table we have done. Then for method 3, we just sum all the probabilities from 5 to 15, and all the 3 methods give the same answer, which is 0.110.
So for here, we are showing a graph with the binomial distribution for the students who do not taking a note. The x-axis represents the number of students who do not taking notes, and the y-axis shows that the probability of the outcome. So for a graph, we can see that the highest probability is near x equal to 2 and x equal to 3, which is the curve bit, and this means it's most likely that 2 or 3 students do not take note. For the outcome greater x equal to 5, and the probability drops sharply and approximately 0. So it's very unlikely for the more than 5 students do not take notes, and we can see the majority for the outcome are concentrated around 2 until 4 students not taking the notes. So let's connect this situation into the classroom. If you randomly check, you are mostly like to find 2 or 3 students not taking a note, and there are almost no chance that all the 15 students or even X students are not taking the note. Instead of using a line graph, we may visualize the probability by using the histogram.
Moving on for question 3. On average, studying students do not watch Dr. Johnson's recorded lectures until the end, and what is the probability that exactly 2 students will not watch the recently uploaded lecture until the end. Assume that the number of students who do not complete the recorded lecture follows a Poisson distribution. Create a visualization of the probability distribution to illustrate the probabilities for different numbers of students who will not watch the recently uploaded lecture until completion. Express the probability values in 3 decimal places. So from question 3, we know that the mean is 13, which this means the total outcome will be 26 since the mean is multiplied by 2, and the number of students who did not complete the recorded lecture, denoted as X, is 10. And to compute the Poisson distribution, we will use the formula equal Poisson distribution, parenthesis, outcome X, mean and the cumulative. Here the cumulative parameter is set to false since we are calculating the probability distribution, not the cumulative probability. So applying this formula, we find that for X equals to 10, the result will be 0.085870151. And to calculate the Poisson probabilities for other outcomes from 0 to 26, we will apply the same formula, which is equals Poisson distribution, parenthesis, outcome X, mean and then cumulative. And then finally, using the computed probabilities, we generate a line plot to visualize the Poisson distribution of each outcome, and then the corresponding values are then listed in the table on the left side of the graph.
As you can see here, the chart above displays a Poisson distribution for the number of students who do not complete the recorded lecture. And as you can see from the Poisson distribution, you can see that the peak is 13 students, which is also the mean, where this means that this is the most common number of students who do not complete the recorded lecture. And the Poisson distribution is also skewed slightly to the right, where most probabilities are concentrated between 8 to 16 students, meaning disengagement usually falls in this range. But beyond that range, the likelihood of these students do not complete watching the recorded lecture drops significantly. And this data will give the doctor a clearer idea of engagement patterns between the students and can help the lecturer to find ways to keep students more involved in the lectures. That wraps up our analysis of scenario 2.3, where we did analysis of students' information, note-taking habits, and finally the number of students who do not complete recorded lectures. We hope the Excel guide, formulas, graph, and summary we provided help give a clear understanding of the scenario and the questions involved. Thank you.